So let's talk about potential x and y axis. I think time's the easier one. Who thinks they have a unit of time that we should consider? Sean? Seconds. I'll let you know another one I heard out there. Minutes. I would argue that 6 minutes to raise the flag might be excessive. Let's test it out. Everybody watch the clock. Go. I'm pretending like I'm raising it.
Really slow.
6 minutes.
Hey, we're only 6 seconds in right now, Troy. Yeah, okay, so keep watching the clock because I don't want to go over 6 minutes. I want to use my time really efficiently.
What about yards?
6
I think
minutes.
it's been 6 minutes.
6 minutes late.
Oh, it seems like it's taking a while. Maybe minutes is unrealistic. Okay, let's go with seconds.
What about
Segunda. So, the x-axis is going to be seconds. Okay, what about our y-axis? Zip.
For height, I would say meters.
Meters. Here's 2 reasons to say meters. Just to mess with people that see the American flag and then we go metric, right?
Exactly.
Also, it gives us 6, right?
6 feet.
Right? So you could say yards maybe, but feet doesn't make sense. That'd be a pretty short flagpole.
That'd be like.
All right. We've got our x and y axis. Now the different tables, each for your next thing on there, 1A and B, each table is going to take a different graph. So that table up there, you're 1, 2, 3, 4, 5, 6. I meant to say letters. A, B, C, D, E, F. All right, get after it. Group A, what's going on in your situation? Pick a.
steady rate?
What's the steady rate?
Flag going up.
The flag goes up 6 meters over 6
Seconds.
seconds, so meter per second. Constant rate of change might be a thing that we could say for that. All right, B.
Gotta be a peak.
Extra.
The flag stayed at 3 meters the entire time.
Yeah, half mast never moved, right? The whole time. C.
The guy raised it up 2 meters, then took a little break, and then he cranked it until 6 meters in 3.5 seconds.
Yeah, I took a little break in the middle there. D. Troy.
What? I thought that was okay.
No, I got Troy. I was watching the conversation, so I was like, Troy needs to.
Okay. So the first guy could be the same person.
We're doing D.
Yep.
He cranked it up to 2 feet or 2 meters,
Mm-hmm.
and then he let go of it, and he keeps repeating that process until the end.
Yeah.
Till-
I call D the DJ graph because for some reason when I see
Nice
it,
job, Tron.
when I see it in my head, I go wiki wiki wiki. I don't know why. Yeah. All right, E. All right, Vinny, E. What's going on at E?
I said somebody pulled. It started at 0.5 yards. Somebody pulled it, and then pulled it a meter, took a break. Pulled it a meter, took a break for a second each time.
Yeah, I get that because like if you imagine like there's a couple ways you can do it. You can be like shimmying it, or like grabbing a string and walking away, or like.
My question is, how do they do that in such a quick amount of time?
They have
Another
6
time.
seconds? Watch 6 seconds. It's not crazy.
Caleb does.
All right, F.
3 minutes.
All right, Cam.
So the person here, he goes really fast, puts it up to 6 meters, then he falls down. And then he catches it again. and
Catches
then-
it exact halfway down.
Yeah.
How did he fall? Just
He just slipped.
He tripped.
he slipped
Slipped on the
standing
hill.
there.
Yeah.
I like
He
it.
wasn't scared.
I thought maybe he got stung
Yeah,
by a
he
bee.
was sturdy
but-
with it.
Okay, cool. So we have good explanations for all of these. Here's what I want to talk about next. Let's just go through on a scale of 1 to 5. 5 being like for sure could be the most realistic, and 0 being like that probably wouldn't happen. Let's try to rate these on a scale of 1 to 5. 5 is like for sure that could be a real thing happening. 1 is like not likely. So, A,
It's pretty realistic.
what do you think on a 1 to 5 scale?
I'll give it a 4.
give it a 4.
Give it a 1.5.
I'm giving it 3 based on a technicality myself. I see some people not putting up numbers. You can't even be wrong on this. Okay, but I'm giving it a 3 just because I'm like that exact constant rate. That'd be hard to achieve unless you had like a winch or something.
Yeah.
Okay,
So
so I gave it 3.
after it gets
B.
How does it
a
just
5.
start at?
I got a 5er.
Because you wouldn't have to
Yesterday, bro. Yesterday.
Because you wouldn't have to touch it.
It was just there yesterday.
Yeah, but if it's hazmat, it means someone died. Did someone die the next day too?
Every day, actually. Okay, C. What are you thinking for C?
Zero. I'm gonna think it's like nobody's pulling a 4.
I'm going back to like a 3 or 4. I think, hey, some people get a little winded right in here. It's not exactly a constant rate. There's some fluctuation. So I've got a 3 or 4 on C. D.
It's quite big.
Put it up, man. I'm looking for these ratings.
Mr. Mack, I don't get how.
I've got a 1 on it. Like you could make it
Maybe
happen.
like a half.
Yeah, I'm
We're
giving.
not gonna be really fun.
I'm giving it a 1 because one of you are just going to go do this because you're like, I'm going to make Mr. Mac wrong.
I think I'll give it a half.
E. Put it up.
5.
That seems realistic.
I've got like a 5 or a 4.5. I think like a. Now, how even the intervals are, that's where I'm not. I'm a 4.8 maybe. Okay, how even that is.
Yeah.
And then F.
Yeah,
He got stuck. He fell down, Kansas. I'm gonna give that a 3 or a 4.
no, but if you fall down, you're pulling it higher up.
But falling down exactly where it hits the top and then falling exactly there. So I'm gonna go. It could happen. All these could happen, and it's kind of fun just to imagine it happening.
Somebody's good.
Next question. 2, B, and C. I'm only going to give you a minute. Can this represent a height and time of flag? And then is it a function? Get after it. So, let's just take a vote. Who thinks this can happen? Who thinks it can't? Who can tell me why it can't? Josiah.
Because that, since it's all like on 1 second, it means there'd have to be like a ton of different flags because it's at multiple heights.
Yeah, this would have to actually be infinite flags. The whole length of the flagpole, all at 3 seconds only.
Yeah,
So,
I guess if the flag was like super huge.
even if it's huge, you're going to have 1 reference point for measurement, right? It's only going to be 1 distance of the flagpole. So, yeah, so is it a function?
No.
No, who can tell me why it's not a function? Brendan.
Because functions can only have 1 input.
Yeah, and input 3 right here has how many outputs? No, functions can have lots of inputs, but each input,
Has to have one.
so input 3 has infinite outputs. That's a problem. So it can't happen in context, and it's also not a function. Okay, I'm going to show you a video. It's your job to sketch this flag raising. Now, I'm going to show this video several times. Take my advice. First hour did, second hour didn't. First hour did better on this. Make a table to record data, because if otherwise you're only able to catch 1 data piece per watch. Make a table to collect data. So if it's a flag raising, we're going to have what 2 chunks for data? Time and height. Maybe you don't even want to make your height unit yet. Maybe you have discussion on that, but you're going to want a time and height in your table. Let's see. I'm skipping this one. I'm only going to do the halftime one, and I'm interested to see how this is going to work while I'm running this thing on my computer. Let's see. It's not funny.
It's hilarious.
What just happened?
I think it is.
Play. Nope.
Look at that.
This computer is not happy about whatever I'm clicking. So I'm going to go, instead of clicking the iPad, I'm going to click the computer. We're good. We're doing this. We're doing this.
Hey, that's my boy, Daniel.
Dang, Daniel. Okay. Here we go. So if you're a person at home watching the YouTube video, I'm only going to play this once for you, and then you can just rewind it as many times as you want.
That's my
You're the
point.
same
Exactly.
line over and over again. You tell you have to rewind, right?
I'm going to play this like 8 times for us in class.
Oh no.
But we should be catching data already. Like, here's where it's at, here's where it's at, here's where it's at. Let's go.
This is quite challenging.
Oh, that's good. Another thing I like doing is like drawing like just a really rough sketch of what's happening and then going to get numbers and then drawing it with the numbers. But all right, that's that. Let me take you through the sketch I had, okay? Because it's going to be hard to go back and forth. What I chose to do along my x-axis, we're looking at our x-axis. It's got seconds. That's what I did. Anybody else do seconds? And I had to go by twos to get it to fit. Okay, I'm going to do this different. I'm not doing it like this. Because I already did this. I'm going to do it like this. So here's what I did. You'll see my table here where I wrote down my values in a moment. Oh, I can make that bigger, maybe. You're going to let me make it bigger? Yep, okay. I was like zoomed in on the page and then... There we go. So out to the right, you can see my XY coordinates I was jotting down as the thing was going. Now, I chose to say not started at the bottom. Be honest, anybody started at the bottom? It's all right if you did. Yeah, but when I was looking at him, like the flag wasn't on the ground, so I chose to start it like at 6 feet. I was like, whatever. Maybe that flag's like starting part way up where the guy was holding it or something. And then like Vinny said, I heard Vinny say it. I heard him say it. He said it would didn't go anywhere for a while. So see that little flat chunk I got? Yeah. Then I noticed he raised it, and I was like, maybe it's like almost halfway. So there he is raising it. And then took a little break. He was chilling for a minute. And then I see him raise it again up, most of the way, and that was at 11, 12 seconds. And then he chilled. Do you guys notice he chilled right one more time before the top? Then he raised it to the top, and he's like, I'm here. And at the top, it chilled for a little longer. And then all of a sudden, he slipped. Came all the way back down to where it started, where he was standing.
That looks like a real highway.
It is kind of. So that's how I went about. So I'm not saying they're not going to match exactly, most likely. Okay? But we should have similar pauses. We should have similar times in which we're stopping, right? Because I jotted down all those times as I was watching it on that XY table. Guess how many times it took me watching it?
15.
It was like 3 or 4. 3 or 4. Well, because I was just jotting down multiple points because I had a table ready to go, so I could just look at it and be like, boom, 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 boom. That's why I suggested the table. Last problem for today. We're at a pool party, okay? There's a pool, 2 pools for this pool party. It's going to be fun. A little one and a big one, okay? And they're both getting filled by the same type of hose, meaning the hose that goes in the little one and the hose that goes in the big one, they fill at the same rate, okay, by volume. But what we need to be mindful of in our circumstance here is our factors are going to be that the small pool is 15 inches deep and the large pool is 27 inches deep, okay? We need to know that. And we need to know that S of t is the time in seconds, or minutes. And L of t is the height of the water after t minutes. So S of t is the height of the water in the small pool after minutes. L of t is the height of the water in the large pool. All right? So when you're graphing this, you're going to read your little situations, situation 1, 2, and 3, and you're going to make a little graph comparing the two. Now, we don't have any other data than this, so things just need to be true relative to each other, okay? Relative to each other. So let's check this out. In the first case, how tall is the small pool again?
15 inches.
15. So the small pool, let's say it's going to fill up. Boom, 15 inches. Somewhere like there. And then it's full, right? This is the small pool. Well, here's the deal. The big pool needs to get up to how many inches? 27? 27-ish, almost. And that needs to go like this.
It's gonna go slower.
Yeah, a bunch of people, and it's a mistake I love. A bunch of people made them fill at the same rate. Well, while they do fill at the same rate by volume, my y-axis is not volume. My y-axis is height in inches. And is the bigger pool going to fill the height faster or slower than the little pool?
That's
Slower. Do you guys see what I mean by a good mistake? I went around. Yeah, because then you're like, oh, you're not like, oh, I'm stupid, I don't know what's going on. You're like, oh, I misread that, or I didn't think about details as much as I should. I totally get this. Let me fix it. That's called learning. That's why I mean good mistake, right? So that's situation 1. We good? Okay. Do you guys see what I mean by good mistake there? I loved it.
It's a pretty good.
Like, I'm not like happy you got it wrong. I'm happy that you got it wrong and we could like
You should
make the picture better. So next one, I'm going to do the small one again. The small one's kind of similar for that next one, right? It filled up. Okay. And then is the big one going to fill up? The height going to go up faster or slower?
Slower.
Slower. But what happens when the small one gets full?
They're shut off. So
They shut it off.
Mine doesn't look like that, but it looks somewhat.
Yeah, just it needs to be similar. Okay. My B looked weird because I was going to go a little B and then I want a big B.
Exactly like proportional to it.
Yeah. Do you see what I'm saying? Why that's like? Okay. I was tempted to make it fill at the same rate too. If the y-axis were volume, sure, but the y-axis is not volume. Okay. In third situation, again, the small one's filling up to the 15, right?
I think I got this one right.
The large one then would be less, and I'm just exaggerating this. And then what happens? They stick that hose in the other one, and then theoretically, twice as fast technically, but then the big one can fill faster. Cool?
Yeah.
It's just rough sketches, right? It's a little sketchy, but it's good.
This situation 3 seems the most realistic.
I think they're all realistic within context, but so let's make sure we can do all the things to do. All right. Let's get to our lesson summary here. We're skipping the ball bounce. We're good. We don't need it. So, explain the average rate of change. Yes, we can do it over this interval. It's this. Make sense of features of graphs and explain what they mean. We practiced a lot of that today. We went video to graph. We went graph to situation. We went situation to graph, right? Different representations because math is communication. That's essentially what all this says. All right, let's get the homework going.